Pipeline transport is the transportation of goods or material through a pipe. The best data, in 2014, gives a total of slightly less than 3.5 million km of pipeline in 120 countries of the world. The United States had 65%, Russia had 8%, and Canada had 3%, thus 75% of all pipeline was in 3 countries. Pipeline and gas journals worldwide survey figures indicate that 118,623 miles of pipelines are planned and under construction. Of these, 88,976 miles represent projects in the planning and design phase. 29,647 miles reflect pipelines in various stages of construction. Liquids and gases are transported in pipelines, and any chemically stable substance can be sent through a pipeline. Pipelines exist for the transport of crude and refined petroleum fuels, such as oil, natural gas and biofuels, and other fluids including sewage, slurry, water, and beer. Pipelines are useful for transporting water for drinking or irrigation over long distances when it needs to move over hills, or where canals or channels are poor choices due to considerations of evaporation, pollution, or environmental impact. Pneumatic tubes using compressed air can be used to transport solid capsules. Oil pipelines are made from steel or plastic tubes which are usually buried. The oil is moved through the pipelines by pump stations along the pipeline. Natural gas are lightly pressurized into liquids known as natural gas liquids. Natural gas pipelines are constructed of carbon steel. Highly toxic ammonia is theoretically the most dangerous substance to be transported through long-distance pipelines, but accidents have been rare. Hydrogen pipeline transport is the transportation of hydrogen through a pipe. District heating or teleheating systems use a network of insulated pipes which transport heated water, pressurized hot water or sometimes steam to the customer. Pipelines conveying flammable or explosive material, such as natural gas or oil, pose special safety concerns, and there have been various accidents. Pipelines can be the target of vandalism, sabotage, or even terrorist attacks. In war, pipelines are often the target of military attacks. Oil and natural gas. It is uncertain when the first crude oil pipeline was built. Credit for the development of pipeline transport is disputed, with competing claims for Vladimir Shukov and the Branobel Company in the late 19th century, and the Oil Transport Association, which first constructed a 2-inch wrought iron pipeline over a 6-mile tract from an oil field in Pennsylvania to a railroad station in Oil Creek, in the 1860s. Pipelines are generally the most economical way to transport large quantities of oil, refined oil products or natural gas over land. Natural gas are lightly pressurized into liquids known as natural gas liquids. Small NGL processing facilities can be located in oil fields, so the butane and propane liquid under light pressure of 125 pounds per square inch can be shipped by rail, truck or pipeline. Propane can be used as a fuel in oil fields to heat various facilities used by the oil drillers or equipment and trucks used in the oil patch, e.g. propane will convert from a gas to a liquid under light pressure, 100 psi, give or take depending on temperature, and is pumped into cars and trucks at less than 125 psi at retail stations. Pipelines and rail cars use about double that pressure to pump at 250 psi. The distance to ship propane to markets is much shorter as thousands of NGL processing plants are located in oil fields or close by when a number of pipelines tie into each other from various relatively close fields. Many Bakken Basin oil companies in North Dakota, Montana, Manitoba and Saskatchewan gas fields separate the NGLs in the field, allowing the drillers to sell propane directly to small wholesalers, eliminating the large refinery control of product and prices for propane or butane. The most recent major pipeline to start operating in North America is a Trans-Canada natural gas line going north across the Niagara region, bridges with Marcellus shale gas from Pennsylvania and others tied in methane, or natural gas sources, into the Canadian province of Ontario as of the fall of 2012, supplying 16% of all the natural gas used in Ontario. This new U.S.-supplied natural gas displaces the natural gas formerly shipped to Ontario from Western Canada in Alberta and Manitoba, thus dropping the government-regulated pipeline shipping charges because of the significantly shorter distance from gas source to consumer. Compared to shipping by railroad, pipelines have lower cost per unit and higher capacity. Pipelines are preferable to transportation by truck for a number of reasons. Employment on completed pipelines represents only 1% of that of the trucking industry. To avoid delays in U.S. government regulation, many small, medium and large oil producers in North Dakota have decided to run an oil pipeline north to Canada to meet up with a Canadian oil pipeline shipping oil from west to east. This allows the Bakken Basin and Three Forks oil producers to get higher negotiated prices for their oil because they will not be restricted to just one wholesale market in the U.S. The distance from the biggest oil patch in North Dakota is Williston, North Dakota, only about 85 miles or 137 kilometers to the Canadian border and Manitoba. Mutual funds and joint ventures are big investors in new oil and gas pipelines. In the fall of 2012, the U.S. began exporting propane to Europe, known as LPG, as wholesale prices there are much higher than in North America. As more North American pipelines are built, even more exports of LNG, propane, butane, and other natural gas products will occur on all three U.S. coasts. To give insight, North Dakota's oil production has grown to 5 times in late 2012 compared to what it was just 6 years ago, creating thousands of good-paying long-term jobs. North Dakota oil companies are shipping huge amounts of oil by tanker rail car as they can direct the oil to the market that gives the best price, but pipelines are cheaper. Rail cars can be used to avoid a congested oil pipeline to get the oil to a different pipeline and get the oil to market faster and different less busy oil refineries. Enbridge in Canada is applying to reverse an oil pipeline going from east to west and expanding it and using it to ship Western Canadian bitumen oil eastward. From a presently rated 250,000 barrels equivalent per day pipeline, it will be expanded to between 1 million to 1.3 million barrels per day. It will bring Western oil to refineries in Ontario, Michigan, Ohio, Pennsylvania, Quebec and New York by early 2014. New Brunswick will also refine some of this Western Canadian crude and export some crude and refined oil to Europe from its Deepwater Oil ULCC loading port. Although pipelines can be built under the sea, that process is economically and technically demanding, so the majority of oil at sea is transported by tanker ships. The Enbridge-Sandpiper pipeline is proposed to transfer fracked oil from western North Dakota through northwestern Minnesota, where 1/5 of the world's fresh surface water lies. The pipeline will be 24 to 30 inches in diameter. It will carry over 300,000 barrels of oil a day with a volatility of 32. Growth of market. The market size for oil and gas pipeline construction experienced tremendous growth prior to the economic downturn in 2008. The industry grew from $23 billion in 2006 to $39 billion in 2008. After faltering in 2009, demand for pipeline expansion and updating increased the following year as energy production grew. By 2012, almost 32,000 miles of North American pipeline were being planned or under construction. Construction and operation. Oil pipelines are made from steel or plastic tubes within a diameter typically from 4 to 48 inches. Most pipelines are typically buried at a depth of about 3 to 6 feet. To protect pipes from impact, abrasion, and corrosion, a variety of methods are used. These can include wood lagging, concrete coating, rock shield, high-density polyethylene, imported sand padding, and padding machines. Crude oil contains varying amounts of paraffin wax, and in colder climates wax buildup may occur within a pipeline. Often these pipelines are inspected and cleaned using pigging, the practice of using devices known as pigs to perform various maintenance operations on a pipeline. The devices are also known as scrapers or go devils. Smart pigs are used to detect anomalies in the pipe such as dents, metal loss caused by corrosion, cracking or other mechanical damage. These devices are launched from pig launcher stations and travel through the pipeline to be received at any other station downstream, either cleaning wax deposits and material that may have accumulated inside the line or inspecting and recording the condition of the line. For natural gas, pipelines are constructed of carbon steel and vary in size from 2 to 60 inches in diameter, depending on the type of pipeline. The gas is pressurized by compressor stations and is odorless unless mixed with a mercaptan odorant where required by a regulating authority. Ammonia. Highly toxic ammonia is theoretically the most dangerous substance to be transported through long-distance pipelines. However, incidents on ammonia transporting lines are uncommon, unlike on industrial ammonia processing equipment. Alcohol fuels. Pipelines have been used for transportation of ethanol in Brazil, and there are several ethanol pipeline projects in Brazil and the United States. The main problems related to the transport of ethanol by pipeline are its corrosive nature and tendency to absorb water and impurities in pipelines, which are not problems with oil and natural gas. Insufficient volumes and cost-effectiveness are other considerations limiting construction of ethanol pipelines. Coal and ore. Slurry pipelines are sometimes used to transport coal ore from mines. The material to be transported is closely mixed with water before being introduced to the pipeline. At the far end, the material must be dried. One example is a 525-kilometer slurry pipeline which is planned to transport iron ore from the Minas Rio mine to the port of ACU in Brazil. An existing example is the 85-kilometer Savage River slurry pipeline in Tasmania, Australia, possibly the world's first when it was built in 1967. It includes a 366-meter bridge span at 167 meters above the Savage River. Hydrogen. Hydrogen pipeline transport is a transportation of hydrogen through a pipe as part of the hydrogen infrastructure. Hydrogen pipeline transport is used to connect the point of hydrogen production or delivery of hydrogen with the point of demand. With transport costs similar to CNG, the technology is proven. Most hydrogen is produced at the place of demand with every 50 to 100 miles an industrial production facility. The 1938 Rhine-Ruhr 240-kilometer hydrogen pipeline is still in operation. As of 2004 update, there are 900 miles of low-pressure hydrogen pipelines in the US and 930 miles in Europe. Water. 2 millennia ago, the ancient Romans made use of large aqueducts to transport water from higher elevations by building the aqueducts in graduated segments that allowed gravity to push the water along until it reached its destination. Hundreds of these were built throughout Europe and elsewhere, and along with flour mills were considered the lifeline of the Roman Empire. The ancient Chinese also made use of channels and pipe systems for public works. The famous Han Dynasty court eunuch Zhang Rang once ordered the engineer by land to construct a series of square pallet chain pumps outside the capital city of Luoyang. These chain pumps serviced the imperial palaces and living quarters of the capital city as the water lifted by the chain pumps was brought in by a stoneware pipe system. Pipelines are useful for transporting water for drinking or irrigation over long distances when it needs to move over hills. or where canals or channels are poor choices due to considerations of evaporation, pollution, or environmental impact. The 530 km Goldfields water supply scheme in Western Australia using 750 mm pipe and completed in 1903 was the largest water supply scheme of its time. Examples of significant water pipelines in South Australia are Morgan Whyalla Popelna and Mano Adelaide pipelines, both part of the larger Snowy Mountains scheme. There are two Los Angeles, California aqueducts, the Owens Valley Aqueduct and the second Los Angeles Aqueduct, which also include extensive use of pipelines. The Great Man-Made River of Libya supplies 3,680,000 cubic meters of water each day to Tripoli, Benghazi, Sirte, and several other cities in Libya. The pipeline is over 2,800 kilometers long, and is connected to wells tapping an aquifer over 500 meters underground. Other systems. District heating or teleheating systems consist of a network of insulated feed and return pipes which transport heated water, pressurized hot water or sometimes steam to the customer. While steam is hottest and may be used in industrial processes due to its higher temperature, it is less efficient to produce and transport due to greater heat losses. Heat transfer oils are generally not used for economic and ecological reasons. The typical annual loss of thermal energy through distribution is around 10%, as seen in Norway's district heating network. District heating pipelines are normally installed underground, with some exceptions. Within the system, heat storage may be installed to even out peak load demands. Heat is transferred into the central heating of the dwellings through heat exchangers at heat substations, without mixing of the fluids in either system. Beer bars in the Veltins Arena, a major football ground in Gelsenkirchen, Germany, are interconnected by a 5-kilometer-long beer pipeline. In Randers City in Denmark, the so-called Thor beer pipeline was operated. Originally, copper pipes ran directly from the brewery, but where the brewery moved out of the city in the 1990s, Thor beer replaced it with a giant tank. A beer pipeline has been proposed for construction in Bruges, Belgium to reduce truck traffic on the city streets. Brine, the village of Hallstatt in Austria, which is known for its long history of salt mining, claims to contain the oldest industrial pipeline in the world, dating back to 1595. It was constructed from 13,000 hollowed-out tree trunks to transport brine 40 kilometers from Hallstatt to Ebensee. Milk between 1978 and 1994, a 15 kilometers milk pipeline ran between the Dutch island of Ameland and Holwood on the mainland, of which 8 kilometers beneath the Wadden Sea. Every day, 30.000 liters of milk produced on the island were transported to be processed on the mainland. In 1994, the milk transport was abandoned. Marine pipelines. In places, a pipeline may have to cross water expanses, such as small seas, straits and rivers. In many instances, they lie entirely on the seabed. These pipelines are referred to as marine pipelines. They are used primarily to carry oil or gas, but transportation of water is also important. In offshore projects, a distinction is made between a flowline and a pipeline. The former is an intrafield pipeline, in the sense that it is used to connect subsea wellheads, manifolds and the platform within a particular development field. The latter, sometimes referred to as an export pipeline, is used to bring the resource to shore. The construction and maintenance of marine pipelines imply logistical challenges that are different from those on land, mainly because of wave and current dynamics, along with other geohazards. Functions. In general, pipelines can be classified in 3 categories depending on purpose. Gathering pipelines, group of smaller interconnected pipelines forming complex networks with the purpose of bringing crude oil or natural gas from several nearby wells to a treatment plant or processing facility. In this group, pipelines are usually short a couple of hundred meters and with small diameters. Also, subsea pipelines for collecting products from deep water production platforms are considered gathering systems. Transportation pipelines, mainly long pipes with large diameters, moving products between cities, countries and even continents. These transportation networks include several compressor stations in gas lines or pump stations for crude and multi-products pipelines. Distribution pipelines, composed of several interconnected pipelines with small diameters, used to take the products to the final consumer. Feeder lines to distribute gas to homes and businesses downstream. Pipelines at terminals for distributing products to tanks and storage facilities are included in this group. Development and planning. When a pipeline is built, the construction project not only covers the civil engineering work to lay the pipeline and build the pump compressor stations, it also has to cover all the work related to the installation of the field devices that will support remote operation. The pipeline is routed along what is known as a right-of-way. Pipelines are generally developed and built using the following stages. Open season to determine market interest. Potential customers are given the chance to sign up for part of the new pipeline's capacity rights. This stage lasts up to 2 months. If interest in the pipeline is limited, the project does not move forward. Route selection. Pipeline design. The pipeline project may take a number of forms, including the construction of a new pipeline, conversion of existing pipeline from one fuel type to another, or improvements to facilities on a current pipeline route. The design process may take up to 6 months. Obtaining approval. Once the design is finalized and the first pipeline customers have purchased their share of capacity, the project must be approved by the relevant regulatory agencies. The process can last up to 18 months, particularly for pipelines that span multiple states. Surveying the route, clearing the route, trenching, main route and crossings, installing the pipe, installing valves, intersections, etc., covering the pipe and trench, testing. Once construction is completed, the new pipeline is subjected to tests to ensure its structural integrity. These may include hydrostatic testing and line packing. Russia has pipeline troops as part of the RIA services, who are trained to build and repair pipelines. Russia is the only country to have pipeline troops.